So, dann nochmal Hallo zusammen. Der nächste Vortrag ist von Philippe Cloup.
Thank you. So, sorry, I will do it in English. I'm not German speaking, or I can do it in French if you want, as you prefer. Probably English would be great. So my goal is to explain how F5 solution can be enabled in an OpenStack environment from different angles. I mean, at the platform level and also at the application level. And the goal is to drive you through different iterations we've done in F5 on what should be the best way of enabling F5 solution in OpenStack. Who is familiar with F5 solutions, actually? If you can raise your hands, yeah? Okay. And who never heard about F5 at all? No? I mean F5 as a brand, not as a keyboard, you know. Okay, good. So I will try to switch between basics about F5 and more in-depth stuff. So my agenda for this session is more or less like this. So it will be a mix between LBAS, because that's where ADC, meant for Advanced Delivery Controller or Application Delivery Controller, is meant for, but also the orchestration layer, where there are other things you can leverage from an F5 platform. So first thing is, as F5 company, we are a vendor, and it's sometimes difficult to talk about open source integration when you are a vendor. And I'm not saying it's good, it's bad, it's how it is actually mainly in the market. So when we work with partners that are vendors, as F5, we try to enable some business development resources. Those guys are linked with the other vendor and making things more fluent and smooth when we integrate together. With OpenStack, there was, let's say, a bit of difference for us, because of course we can have strong partnership with vendors or some OpenStack variations, I would say, Mirantis, Red Hat, or even Nuage or other companies that are using part of OpenStack or most of the OpenStack flavors. But for us, we wanted to make it more the OpenStack way. I mean, as a vendor, we need to follow more or less the rules defined by the community in a way, and trying to adapt our model to those rules. So what we've done is first to create really dedicated teams to work on the OpenStack integration. So of course, we leverage our system, our brand into the OpenStack model. But the goal is to have those guys focused only on this OpenStack way of doing things and not being always pushed by the company saying, how much money can you take from that, and those kind of things. So we started by delivering this with our community website called devcentral.f5.com, where we have roughly multiple hundred thousands of users consuming our resources to develop what we call IOLs for a kind of scripting language for application management and traffic management. And we developed the LBAS plugin integration with the agent and the driver and pushed that into devcentralf5.com. The thing is that this website is a community-driven website, which means that you have F5 users, F5 developers, people that are working for F5 or working for a customer that can put some content there, but there is no kind of guarantee on this content and not kind of support on this content. So this was a way for us to start with the OpenStack integration by providing a solution as is, let's say. but it wasn't following the standard of support we have as an F5 company. So if we wanted to be serious on having this solution enabled in OpenStack, this wasn't following our standard in terms of issue tracking, support, being able to fix issues, and so on. So what we've done recently, I think it was announced officially in Austin, Texas for the OpenStack Summit. We've published on GitHub all the code for the LBAS v1, LBAS v2, its templates, documentations, everything. And available on GitHub, of course, you have versioning, you have the ability to open support, to have issues being tracked. So as a F5 company, of course, we have our support model. And when you enable here, or when you create and log a case for an LBAS v1 or v2 integration, for example, we track this with our standard system, and we have kind of double ticketing system just to check that you are following the standard of support as a vendor. So now we've got, as I said, a dedicated team in terms of development, in terms of testing, in terms of course, product management. And this team is actually based in Boulder, that's the picture here, in Colorado. And so we started with LBAS v1 a while ago, and now we are with LBAS v2, which was announced also in Austin, Texas in April. And we announced also a program for many other components, like a firewall as a service, like acting as an L3 router in the OpenStack environment, and those kind of things. So as I said earlier, there is a kind of ecosystem when we work with partners. Here we have an ecosystem with OpenStack partners or solution embedded on top of those vendors. And we try to have most of the certifications, let's say, with most of those ones. Actually, we have one with Marantis, we have one with Red Hat, with HP, it's been done with HP Helion. So there are a few ongoing ones also, but the goal is really also to support the OpenStack flavors and not especially one type of OpenStack. So usually our customers deploy our platform, which is called for a virtual platform, a virtual edition. That's why it's written VE here. And this platform can be downloaded from downloads5.com as, again, as a company providing a supported version of software. But this virtual edition is meant to be installed on top of hypervisors and not specially for an OpenStack onboarding or deploying a new appliance on top of OpenStack. Which means that if you download this version, you will have to do some manual tasks to be able to enable the platform itself in the OpenStack environment. For interfacing the network layer, let's say, mainly, and also to define how much memory, storage, and so on you need for this platform, which is a bit painful. So what we've done, and it's been also delivered in April in Austin, is change a little bit the way our virtual edition is especially for OpenStack. So in that case, when you download an OpenStack-enabled appliance on our website, this virtual edition is composed of multiple elements where you've got some cloud init scripting, let's say, and scenarios to enable and onboard this platform. Having different flavors for this platform, depending on how much capabilities you want to enable on top of the F5 solution. As I said earlier, F5 as a company, we provide load balancing services with our platforms, but also traffic management, which means providing acceleration in terms of encryption, in terms of caching, compression, but also in terms of security with web application firewalling, for example, and network firewall. But the way our customers consume our resources is mainly always by deploying a cluster, which means active standby scenario. They don't deploy a load balancer just as a standalone. The reason is that we are acting as an L4 to 7 service, and we are stateful, and we are as a kind of TCP proxy and up to layer 7, which means that when a connection is broken because you fail over, you have to recover the connection on the standby. If not, you will break the application layer, more or less. So of course, with HTTP services, in many cases, that's not a big deal because the browser will send again the payload. But for, let's say, a web server that you are load balancing, even if this is not seen as an issue, if you end up by going to a different server when you do the load balancing mechanism because you don't have this persistency information, then you potentially end up by going to the wrong web server, which has no clue of what is this customer. So there are various reasons why a cluster for our customers is relevant into OpenStack environment, and we enable this function also through our virtual edition, especially crafted for OpenStack. Yeah, so someone told me that it's good to have a bunch of text in some slides, so that's why I bring some text there. I'm joking. So here the goal is to show that when you download the VE, it's already defined, let's say, in terms of storage, in terms of resources. It's a quick how-to image. And there are different flavors, mainly depending on how much modules or features you want to enable. As F5, we have a licensing model based on the modules you enable. If you want to enable security modules, it's different than enabling just load balancing functions. So what we are providing with this VE, let's say, and the automation and so on provided with this, of course, it's the OpenStack network service integration through the Neutron LBAS integration, security integration, metadata integration. This is a way to have the platform starting and getting the information from the metadata repository. And the licensing orchestration. There are two ways of licensing a platform as an F5 platform. One is to deploy the platform as, let's say, an online activation model. So the platform will register directly through the internet and get back the license. Or the other one is to get a pool of licensing, and the platform will register to this pool of licensing, where you can enable, disable, or attach, detach the license, depending on the resources you need. Okay, so far, any question? Feel free. Okay. So here I'm talking about the way F5 resources can be enabled in the OpenStack environment. We support different models. The multi-tenant model, where our physical or virtual interfaces or virtual platform, can be enabled and support multiple multi-tenant approach. So how we do that for the guys that are aware of what F5 is providing in terms of functions. We create a partition, where in this partition you have the configuration linked to the tenant. And in this partition, we enable routing domains to enable, let's say, kind of VRF, or being able to have the routing environment being disconnected from the other tenant on the same platform. Or the other one is a single tenant, where in that specific case, a platform is enabled for a single tenant. I've seen the two different options in customer deployments. Usually, there are reasons for one or the other. The multi-tenant approach, you are the one managing the infrastructure, and you give to the tenant resources as servers and so on to enable their application workload, but you manage the infrastructure, I mean the networking layer in many cases. The other one with a tenant enabled as a single tenant, you consume the load balancing services when you need them, and you enable them for your own requirement, let's say. So in this model, I wouldn't go into that detail, let's say, except if you have any questions. We have both options, as I said, multi-tenant or single-tenant with a platform. Usually, the single-tenant is mainly used by customers for virtual editions, where multi-tenant is, in some cases, used with platforms. As the platform we have in our portfolio is able to sustain 1 or 2 terabits of traffic, actually, for L4 to 7, and providing DDoS attack prevention, which is also a value for cloud environments. So, okay, so, sorry. So, in the OpenStack onboarding scenarios, we provide in IT template. There are IT templates to deliver and to provide a virtual edition as a load balancing solution, or even multi-modules platform. And you can reuse those IT templates. They are on GitHub, as I said earlier. And we can orchestrate licensing, boot, SDN integration, and so on from those templates. So I was talking about high availability. High availability in F5 is available as active standby mechanism, or active standby, or active standby. There are different flavors, and we call this DSC, device service clustering, where the goal is really to have, let's say, multiple platforms enabled in a tenant, for example, and being able to place an application in one or the other platform. The goal is to be able to scale, but keep the ability to fail over if one of these platforms is broken. So those different elements, is there laser? Yeah. So those different elements from the LBAS integration are, as I said, multi-tenant enabled, and we also provide different flavors when you deploy the agent by default, where on a single agent description, here it's dev, test, and prod, but you can name them whatever you want. You can enable some specific functions with your LBAS definition. I mean, you've got a central platform where you enable multiple tenants, and for a single tenant, it doesn't make sense to do nothing when you send traffic to the servers. For another tenant, it makes sense because the routing is not the same. So you can enable this in the LBAS definition of the agent, and then create some specific versions, let's say, of this agent, targeting the same platform, but for the tenant that will consume one or the other, it will have a different way of managing the traffic from the load balancer. So what we've done here is just to expose in the LBAS ini configuration some parameters that are relevant for a load balancer that are not specially identified or seen in the LBAS GUI and the LBAS configuration. And we've added something for the service placement, where every device deployed can be per tenant or multi-tenant, as I said, is giving some statistics and metrics. And based on those ones, when you deploy a new application, the new application can target directly the platform that is more relevant at that time, depending on this metric. So this metric is sent every 20, 30, 40 seconds to the LBAS layer. And then we get this information. When you push a new application definition, a new virtual server in most of the cases, we look at the metrics, and based on those metrics, we select the platform to target that is the less, let's say, loaded at that time. Global routed mode is one of the deployment model where the F5 is identified as an infrastructure platform, and you only see from the Horizon GUI virtual server, pool members, monitors, and you don't specify or define any L2, L3 configuration. That's done from the networking layer, and it has no connection, let's say, with the OpenStack, except that you use Horizon to create virtual server, pool monitors from the GUI. The other one, the L2 adjacency model, that's mainly how people consume our service in OpenStack. You have the platform which is multi-tenant, you create vPool and monitors, and the LBAS agent is connected with the F5 configuration and with the OpenStack controller. So any modification, change, addition relevant to the tenant where the F5 is installed has an effect on the F5 platform also. So that's where, let's say, we usually see our platform being deployed, not only with OpenStack, but with other vendors we partner with in the SDN layer. Yeah, so we support multiple LBAS services, as I said when I was talking about dev, test, and prod. And we support also service placement, where here the goal is really to place a new application on the less loaded platform. So that's, let's say, more or less how to enable an F5 platform, few flavors, but that's not especially positioning the F5 into the application layer, where usually we are actually positioned with our customers. So what F5 has developed the last probably 4 or 5 years, because what we've seen with our platform is that if you look into the different features and options, you can spend weeks on learning how to set up the configuration. It's made of multiple thousand entries in terms of configuration. So to help our customers consume our platform and our solution and being aligned with the application requirements, what we've added is a technology we call IAPS, so it's an F5 name, where we use kind of blueprints to define a configuration. So you enable an F5 platform, you want to deploy SharePoint, Exchange, or whatever application, I would say. All the relevant elements required in the F5 platform to be set up are part of this IAP. So the goal is really to manage the life cycle of the application with this configuration and being able also to very quickly deploy a new application, even if this application is really complex. So as shown here, it's made of different things, different layers, the implementation, presentation, and help made in HTML. I would say that the implementation is where we send all the different configuration elements to the F5 platform. Presentation is just here to show an HTML web page to set up the different components. So it's creating a bunch of objects, SSL certificates, optimization for TCP, single sign-on for web applications. Here it's SAML. various things, IOs and so on. So all this complexity, previous to IAPS, you had to spend probably a couple of hours in an F5 platform to set up this. So now with the IAPS, and it's, let's say, 4 or 5 years behind, customers can deploy very quickly an application using this kind of blueprint. So this template is then, yeah, let me go straight on this one. That's pure F5 terms. What this IAP is doing also, and it's really important for cloud-enabled applications, is that when you deploy a new IAP, this IAP can potentially be re-entered. I mean, I deploy an Exchange application, but I've probably miswritten the IP address of the destination server. I can go inside the IAP, see all the different parameters that were pushed, and change one of them. It's running exactly the same code when I do that, which means that I will have this potential kind of issue that will happen, where I've got objects that are kept, objects that are changed, and objects that are removed. And the IAP technology is taking care of that, checking the configuration, the existing configuration, and what are the changes needed, and doing the proper changes in terms of code sent to the F5 platform. Why is this important? It's important for two things. One, first, it means that you can use IAPS to reprovision or to change a configuration. Looking into how customers orchestrate some of the application layers or provisioning even our platform, sometimes they think about sending REST API calls. When you send REST API calls, and if there is something wrong in the middle, you have to revert everything, or you have to identify what is wrong and do the proper changes in between, which means that potentially you will have to spend time on this kind of issue. Here, when you think about IAPS, it's already managed. If I send again the same request to the same IAP, then the result would be nothing, because the objects are already there is no change, I change nothing. If there is a slight change in one of the parameters, this parameter is changed directly and all the others are untouched. And if the application is running at that time, I'm not impacting the application by deleting and creating the application again. I'm just changing one of the parameters. The reason why I'm saying that is that the REST API is capable of calling an IAP with our platform, which means that instead of going through 1,000 entries of configuration using REST, you can go through a single REST API call, which will leverage probably 1,000 configuration elements in an F5 platform, but that's the IAP work, and it's local to the F5 platform in that case. So of course, yeah, that's a REST call where I'm calling the list of application templates, and from one of the templates, I'm sending, sorry for that, but I'm sending the multiple parameters and values I want to put through the IAP. So here I'm calling using a post REST call. I'm calling an IAP and sending parameters. And of course, I've got the same level of information on the platform itself. So what we've done with IAPS, and back to the topic of OpenStack here, is we've enabled it templates and what we call an F5 IAP plugin in it to leverage IAPS. So when you call from it a stack with a targeted F5 platform, which is hosting a template, then you can name the template, and you can pass some of these IAP parameters. I'm not sure if you can see it. It's written F5sys IAP service. And those parameters are there and are specific, let's say, to F5, but available through the it template layer. So in that case, HTTP compression on the client side, caching on the client side, and so on and so forth. All the F5 features are available through this IT orchestration layer. So why we've done this this way, especially, if we stick to the LBAS plugin integration, then we are narrowing more or less the F5 value and features we have, even as a load balancer. When our customers consume F5 load balancing resources, they usually use IURs, which is a way to extract information from the traffic. They usually do caching of web objects. They usually do compression of web objects. Those features and capabilities were not, let's say, highlighted or available in the LBAS definition, which was more or less, let's say, showing that we are not especially a great solution when enabled in the OpenStack environment. So with the IT integration, there is a way to, using this IAP integration, for example, there is a way to target the LBAS layer or to target an F5 platform, not especially because it's LBAS enabled, and in that case, leverage all the other features and modules capabilities. Not sure if it will run. Let me try. Ooh. So this one is showing an F5 GUI, where, as you can see, there is nothing provisioned on the F5 platform. No virtual server, no configuration, no pools, no pool members. And the goal is to use it to deploy the F5, and of course not only the F5, but also the servers and so on directly. So we load the it template. Here, this is where you have, and we are still in it definition, of course. So you have to set up the different parameters. Those ones are relevant based on what kind of application you want to deploy. Here we are selecting the network connectivity, client side, server side, the IP address of the platform itself if needed. Of course, we can get the IP address from the OpenStack, the login password, and so on. And then we deploy, or we launch the stack. So the F5 logo you see here is linked to the IT template plugin, which is the one calling the IAP and then deploying the F5 configuration through the IAP. Or, of course, there are the other resources in terms of networking and so on. And then all the instances are created with the networking layer and so on. And the IAP here listed has deployed different objects, virtual servers, pools, pool members on the F5 platform. One of the good points here is that the F5 IAP that has been used, if you delete the stack, because the IAP is also called to delete the objects, all the objects that were created by the stack are removed through the IAP mechanism. So you keep the environment, let's say, in a clean position. Roadmap, so talking about what we are targeting, let's say in terms of features. So we already have this. It's been announced in Austin in April. We are actually on this phase where we look into LBAS v2 Mitaka. I think we already announced something, I'm not 100% sure. North-South traffic flows, Marantis Fuel plugin, Red Hat Director plugins. As I said, Red Hat, we get a certification recently. I'm not sure it's publicly announced, but we have one. Marantis version 8, I think we already have something published on the Marantis website. Murano support for virtual edition. For firewall as a service, that's something we plan for the Newton release with different components, the driver and the agent. And it extensions for firewall as a service. And virtual edition auto-scaling. As I said, we partner with some companies. We are also looking into LBAS v2 with Nuage, with SoftLayer, with a few other guys. And then later on, looking at our capability also in DNS environment, because this is one of the big drivers we have also as F5 components. DNS as a service, VPN as a service, some extensions for Horizon GUI, 2-tier SSL offload. Actually, we are able to offload from a virtual platform to a physical platform because in our F5 platforms, we have SSL-enabled chips, and those chips are providing performance for the overall infrastructure. BigIQ integration, that's a central management solution we provide for customers. And the goal is to have this solution being targeted by it instead of targeting directly the F5 platforms. So, any question? I'm open to questions. I'm at the end of my presentation, unfortunately.
So if there are no questions, I say thank you, Philippe, for this interesting speech.
Thank you.